Hello all, welcome to session 3 of Size Exclusion Chromatography. In previous two sessions, we have discussed principle, theory, and what are the things which are required in order to perform a size exclusion chromatography. Application, that is, application of size exclusion chromatography in polymer chemistry. I told you size exclusion chromatographic technique is a separation technique. So what probably would be the application in polymer chemistry? Yes, it is just separation of polymers which have been synthesized. The polymers may be of different sizes, right? So there will be having different molecular weights. So you're going to separate them based on their molecular weights. So we have seen previously in the graph that we have log of molecular weight on the y-axis and elution volume on the x-axis. So depending upon the elution volume, we can easily identify what is the molecular weight of that particular fraction of the compound. Okay, fraction of what has been separated or eluted. So when we discuss about molecular weight, we have two terms in polymer chemistry: weight average molecular weight and number average molecular weight. We shall look at them one by one. Okay, see here, elution volume can be correlated with molecular weight. We have weight average molecular weight, which is equal to sigma mi square ni divided by sigma mi ni. Or we have number average molecular weight mn bar, which is equal to sigma mi ni divided by summation of ni. When you divide these both, weight average molecular weight divided by number average molecular weight, we get dispersivity D. Okay, we can find out these molecular weights using size exclusion chromatographic technique. So based on that, you can find out weight average molecular weight and even number average molecular weight and its dispersivity. Size exclusion chromatography, as we all know, it's not an absolute method. Absolute method means it is one method you can apply and you're going to get accurate results. Obviously not, because depending upon the type of sample, the result is going to vary. Say in one analysis you have synthesized a compound of molecular weight 54, 96 and 100. In another slot of synthesis you have synthesized a molecular weight 25, 50 and 100. So you can't say that both of them are same, right? So they're going to vary. When they are varying, you cannot say this method is absolute. Once you perform, yes, perfect, you have it. This much volume only is going to give you this much molecular weight. Impossible. Hence, what you're supposed to do is, you have to calibrate it. Okay, you're supposed to calibrate it. So you have to elute appropriate calibration standards and monitor elution volumes. So there are calibration standards which are available, which the company provides us. So you have to elute it first and then find out at what volumes what molecular weight compound is going to come out. So we are going to set this equation. So ln of nu m is equal to elution volume, or nu is equal to km to the power of alpha. When we find out this relationship, we can tell that at a particular volume you have a particular molecular weight compound, or else you cannot say it. In order to tell that, you have to calibrate it. Okay, there are two types of calibrations. One is using monodispersive standards. Okay, we call that as narrow mono disperse standards, which are similar to sample. You can have non-aqueous or you can have aqueous. So under non-aqueous we have polystyrene, polytetrahydrofuran and polyisopropene. In hydrophilic, we have dextran, polyglycols, and polystyrene sulfonates. Or we can use universal calibration. Universal calibration. You can use specific calibration or universal calibration. That is, you're going to use Mark-Hoving relationship. It's a linear relationship between solute volume and the logarithm of the product of molecular mass m and the intrinsic velocity of the substance nu. Intrinsic velocity nu. It's this equation. Okay. You can use this equation. This is nothing but Mark-Hoving relationship. And you can elute monodisperse standards and define the relationship between elution volume and molar mass. Here we can find out that at what velocity, what volume is going to come out, and what is the relationship between molar mass. So you universally calibrate it. So you can use this or you can use that. So you're using these two methods, you can calibrate this method, and this after calibration only you can use it to detect the molecular weight of the polymer which has been synthesized. Once you know the molecular weight, you can easily find out what is weight average molecular weight and what is number average molecular weight and calculate its dispersibility. So we have covered so far in session 1 introduction and principles of size exclusion chromatography, and session 2 theory and materials for size exclusion process, and in this session application of size exclusion or gel chromatography in polymer chemistry. So that completes size exclusion chromatography. I hope you have understood. Kindly go through the study material for further understanding, and you can even go through these references, okay, and understand much better. There are few videos which are available. Kindly go through them on YouTube and understand this particular very simple chromatographic technique. Thank you.